In this video, what we're going to do is start looking at functional transforms. And so by definition, these are just Laplace transforms of a specified function of time. So we can think about, for instance, u of t, e to the minus at. We'll look at various other functions in some later videos. But this functional transforms is a specific function of t. And that's going to be opposed to our operational transforms, which we're going to consider later. So the idea with our operational transforms is we're doing some operation and we want to say how does that affect our function in both domains. This language is not the language used in your textbook, but I think it helps these things make a little more sense. So let's start by finding some functional transforms of some common functions in this and the following videos. So let's start with our unit step function. So we've been talking about this a little bit, so let's go ahead and dive into how to do this. So our unit step function, which as we've written before, is just u of t. So let's go back to our basic equation 1 that we had in our previous video, and we're taking the Laplace transform of u of t. So Laplace transform of our unit step function. So essentially, if we're using that equation, we're just going to now substitute for our f of t in that integral. And so for all of these cases, you can come and you can do this each time, but what we're going to see is that ultimately we're going to be using a table for these transform pairs and transform properties. So our f of t has now become u of t, and then we have e to the minus st dt. Okay, again, by definition, remember our u of t is 0 for t less than 0 and 1 for t greater than 0. So essentially, on the range that we're integrating, this just becomes 1. So we just have the integral of 0 minus to infinity of 1 times e to the minus st dt. Okay, so now we just perform that integration, and so doing so, we can see that that is going to be negative 1 over s e to the minus st, and so that's just from our basic derivative of an exponential. We need to keep in mind that we need to do the chain rule in the argument of the exponential when taking the derivative. So that's why we have that negative 1 over s term. And so this is going to be evaluated between t equals 0 and t equals infinity. So plugging in those two values, so first for t equals infinity, we have e to the minus s infinity. So that's 1 over e to the s infinity. So that's going to be 0. Because remember, ultimately, e is just a number, the natural number. And then for t equals 0, so we're at minus. For t equals 0, we have e to the minus s0, so e to the 0 is just 1. So we have minus 1 over s times 1. And so, of course, that is then just equal to 1 over s. So we can say that our first Laplace transform pair that we found is u of t and 1 over s. And so sort of continuing our discussion from the previous video, in this case, if we see the 1 over s in our frequency domain, we can say, okay, that came from a u of t in our time domain, and so that's how we could sort of inverse transform.